Welcome. Let's understand data for data mining. So, what is data? Data is a collection of data objects and their attributes. An attribute is a property or characteristic of an object. For example, an attribute can be eye color of a person or temperature. A collection of attributes distribute an object. Object is also known as point, case, sample, entity or record or an instance. Let's see what are the type of attributes. Different types of attributes are nominal, under which we can have examples like ID number, eye color or zip code. Under ordinal we have examples like rankings, grades or height and tall, medium and short. Under interval we have examples like calendar date, temperature in Celsius or Fahrenheit. Under ratio we have examples of temperature in Kelvin, length, time and count. Let's understand attributes in further detail. Nominal attributes provide only enough information to distinguish one object from the other. Examples would be zip codes, employee ID, eye color, sex, or numbers. And the operations performed on nominal attributes are mode, entropy, contingency, correlation, and X-square test. And ordinal attributes are the values which provide enough information to order objects. Examples would be hardness of minerals, grades, and street numbers. The operations performed on ordinal attributes are percentiles, median, rank correlation, run and sign test. Let's see what is interval attribute. For interval attributes, the difference between the values are meaningful. That is, a unit test of measurement exists. Examples are temperature in Celsius and Fahrenheit or calendar dates. The operations performed are mean, standard deviation, Pearson's correlation, T and F tests. Ratio attribute. For ratio variables, both differences and ratios are meaningful. Examples are temperature in Kelvin, monetary quantities, counts, age, mass, length, and electrical current. The operations are geometric mean, harmonic mean, and percentage variation. Let's understand discrete attribute. Discrete attribute has only finite or countable infinite set of values. For example, discrete attributes might be zip codes, count, or set of words in a collection of documents. These are often represented as integer variables. Note that binary attributes are special case of discrete attributes. Continuous attribute has real number of attribute values. For example, temperature, height or weight are continuous attributes. Practically, real values can only be measured and represented using finite number of digits. Continuous attributes are typically represented as floating point variables. Let's see what are types of data sets. Record data set we have data matrix, document data and transaction data. And a graph data set we have World Wide Web, molecular structures. And the order data set we have spatial data, temporal data, sequential data and genetic sequence data. What are the important characteristics of structured data? They are dimensionality, sparsity where only presence counts, or resolution where the pattern depends on the scale. Data quality. What kinds of data quality problems might occur? How can we detect problems with the data? What can we do about these problems? Some of the examples of data quality problems are noise and outliers, duplicate data and missing values. Data processing can be done by aggregation, sampling, dimensionality reduction, feature subset selection, feature creation, discretization and binarization, or attribute transformation. Let's understand aggregation in detail. Aggregation is combining two or more attributes into a single attribute. The purpose of aggregation is data reduction, change of scale, and to get more stable data. Let's understand sampling further. Sampling is a main technique employed for data selection. It's often used for both preliminary investigation of data and finally data analysis. Statisticians sample because obtaining the entire set of data of interest is too expensive or time consuming. Sampling is used in data mining because processing the entire set of data of interest is too expensive or it's too time consuming. Let's see what are the types of sampling. We have simple random sampling, where there is an equal probability of selecting any particular item, or we have sampling without replacement, where each item is selected, it is removed from the population. Or under sampling with replacement, objects are not removed from population as they are selected for the sample. In sampling with replacement, the same object can be picked up more than once. Under stratified sampling, first we split the data into several partitions, then draw random samples from each partition. Let's understand dimensionality reduction further. The purpose of dimensionality reduction is to avoid the costs of dimensionality, to reduce the amount of time and memory required by data mining algorithms, to allow data to be more easily visualized. And it may help to eliminate irrelevant features and reduce noise. The techniques used are principal component analysis, singular value decomposition, or supervised and nonlinear techniques can also be used. Let's understand feature subset selection further. It's another way to reduce dimensionality of data. Under redundant features, we have duplicate much or all the information contained in one or more other attributes. Examples would be purchase price of a product and the amount of sales tax paid. Under irrelevant features, we can contain no information that is useful for data mining task at hand. For example, student's ID is often irrelevant to the task of predicting student's GPA. The techniques used are under brute force approach, we try all possible feature subsets as input to data mining algorithm. Under embedded approaches, feature selection occurs naturally as part of data mining algorithm. Under filter approaches, features are selected before data mining algorithm is run. Under wrapper approaches, use data mining algorithm as the block box to find the best subset of attributes. Let's understand feature creation. Create new attributes that can capture the important information in the data set much more efficiently than original attributes. We use three general methodologies like feature extraction, which is domain specific, mapping data to new space, and feature construction, which is done by combining features. Let's understand discretization and binarization. Transforming a continuous attribute into a categorical attribute is known as discretization, whereas transforming both continuous and discrete attributes into one or more binary attributes is known as binarization. Techniques used are original data equal with discretization equal frequency discretization or k-means discretization. Let's understand attribute transformation. A function that maps the entire set of values of a given attribute to a new set of replacement values such that each old value can be identified with one of the new values. Simple functions like x bar k, log x, e bar x or mod x can be used, or standardization and normalization is done here. Let's understand similarity and dissimilarity. Similarity is the numerical measure of how alike two data objects are. It is higher when objects are more alike, often falls in the range between 0 and 1. Dissimilarity is the numerical measure of how different two data objects are. It's lower when objects are more alike, and minimum dissimilarity is usually 0. Suppose P and Q are attribute values of two data objects. Then for nominal attribute type, we have dissimilarity as 1 when P is not equal to Q, and dissimilarity is 0 if P is equal to Q. And similarity is 1 when P is equal to Q and 0 when P is not equal to Q. For ordinal attribute value, dissimilarity is given by the formula of mod of P minus Q by n minus 1. Similarity is given by 1 minus dissimilarity. For interval attribute type, we have dissimilarity given by mod of P minus Q, whereas similarity is minus dissimilarity, or similarity is given by 1 plus dissimilarity, or similarity is given by this formula. 1 minus dissimilarity minus minimum dissimilarity by maximum D minus minimum D. Dissimilarities between two data objects. The distances, we have Euclidean distance and Minkowski's distance. Let's understand Euclidean distance. Euclidean distance is given by this formula, where n is the number of dimensions and pk and qk are respectively the kth attributes or components of data objects p and q. Standardization becomes necessary if scales differ. Let's understand Minkowski's distance. Minkowski's distance is given by this formula, where r is the perimeter, n is the number of dimensions, and pk and qk are respectively the kth attributes of data objects p and q. Similarities between two data objects. Similarities also have some well-known properties, like similarity of P and Q is 1 only if P is equal to Q, and similarity of PQ becomes equal to similarity of QP for all P and Q when it is symmetry, where similarity of PQ is the similarity between points, that is data objects. Let's understand similarity between binary vectors. Common situation is that objects P and Q have only binary attributes. Compute similarities using the following quantities. M of 0, 1 is equal to number of attributes where P was 0 and Q was 1. M of 1, 0 is number of attributes where P was 1 and Q was 0. M of 0, 0 is number of attributes where P was 0 and Q was 1. M of 1, 1 is number of attributes where P was 1 and Q was 1. Simple matching and Jaccard coefficient is given by SMC, which is given by the formula number of matches by number of attributes. It is defined by M11 plus M00 by M01 plus M10 plus M11 plus M00, where J is given by the formula number of 11 matches by number of not both 0 attribute values, that is M11 by M01 plus M10 plus M11. Cosine similarity. Suppose D1 and D2 are two document vectors, then cosine similarity of D1 and D2 is given by the vector product of D1 D2 divided by the length of D1 into length of D2. Take an example of D1 is equal to 3205000200, and if D1 is 100000102, then vector product of D1 and D2 is calculated like this, where nth attribute of D1 is multiplied by nth value of D2 and it's summed up. So we get the sum as 5, and length of D1 vector is calculated by multiplying every nth attribute of D1 with itself and adding all these values raised to power 0.5. So we get the values of D1 length and D2 length as like this. So applying the formula for cos of D1 D2, we get the answer as 0.3150. Extended Chekhov coefficient is given by the formula T of PQ is equal to vector product of P and Q divided by length of P vector whole square plus length of Q vector whole square minus vector product of P and Q. Correlation measures the linear relationship between objects. In order to compute correlation, we first standardize the data objects P and Q, then take their dot product. Pk dash is given by Pk minus mean of P divided by standardized P. Qk dash is given by Qk minus mean of P divided by standard of Q. And correlation of PQ is given by P dash vector dot product Q dash. Sometimes attributes are of many different types, but an overall similarity is always needed. For kth attribute, first compute similarity Sk in range 0 and 1, then find an indicator variable delta of k, which is given by indicator variable is 0 if kth attribute is binary asymmetric attribute and both objects have a value 0, or if one of the object has a missing value of the kth attribute. Indicator value is 1 otherwise. Compute the overall similarity between the two objects using this formula. Take a look at this formula. Using weights to combine similarities. Similarity of P and Q is given by this formula and distance of P and Q is given by this. Using weights WQ, which are in between 0 and 1 and sum is set to 1. That completes our tutorial. So pick up any further tutorial of your choice and browse through it. Our tutorial sections are free and self-guiding. For further help, visit us at www.dataminingtools.net.